Okay, so yeah, hi everyone. So my name is Siddharth. I work as a lead data scientist at Emphasis in their AI team. I'm also here with my manager, Farhat, who's the head of our data science team. So a little bit about the work that we do before I get into why we're approaching this topic. Um, we work quite a bit on like building machine learning solutions for financial services. A few of the things in the recent past have been more geared towards traditional machine learning, things like document classification for investment banking and loan policies. But we are moving more towards building some generative AI solutions. And what we noticed that since we work in the data science team, we generally work with like raw notebooks, whether it's fine-tuning models or even just the whole evaluation process. And when we hand over these models to like an MLE or someone who needs to deploy them into production, we notice that the principles that uh, people generally use for deploying traditional machine learning models in your whole MLOps system aren't quite the same as what you'd see when deploying LLMs. So that's why we began delving a bit more into the practice of LLMOps, which is basically building secure pipelines for large language models. So the agenda for today, I'm basically going to make it as macro or high level as possible. The principles or the things I'll be talking about could apply to someone who's just looking to fine-tune LLMs from scratch, whether it's having their own notebook set up using something like Unslot, or even at an enterprise level where they are looking to scale up their deployed LLMs, whether it's more queries or introducing some principles that can help govern their LLMs when in production. So I'll be walking over a bit on how LLMs are not traditional ML models, what failure modes they have, the overlap that we see between LLMOps and also the MLOps in the ML lifecycle, a proposed three-tier LLMOps architecture that someone can use as a guideline when building their own fine-tuning system. I'll also do a brief code walkthrough of the same and just come through with some best practices that anyone can follow when they're deploying their LLMs in production. So we could get the major thing out of the way. Of course, we know that, LLMs and your traditional models, whether it's classification or regression, they don't have the same architecture. LLMs primarily go based off a transformer-based architecture. But what I wanted to focus on is how LLMs break differently when you have them in production, which is basically the failure modes that you see. You can see that if you just go over this list, these are some familiar risks that you see. One is drift. Drift is something that you see in traditional ML models. You can see data drift or basically some change in distribution. But if you look at LLMs, models behave differently with things here that shift differently, which is instructions or the domain that the LLM has been adapted towards, and various user or prompt patterns that the LLM detects. Another one which we see very commonly nowadays is LLM hallucination, which models can confidently generate false facts. Of course, the screenshot here shows like GPT 3.5 where it confidently gives wrong answers. The new ones have been less prone towards hallucination, but someone, let's say, picking up open source model from, let's say, Hugging Face and trying to fine tune those, they still do see that hallucination does occur when you're feeding it prompts. And unless you're quite familiar with what parameters you're fine tuning, it's quite difficult to try to overturn LLM hallucinations. So this is another thing that needs to be addressed in your LLMOps system. Of course, you have a few other things like prompt injection, which is more of a security risk, where you have to introduce things like guardrails to your LLM because otherwise accidental inputs can override instructions and breaking safety layers. This isn't something that we generally focus on when you're a data scientist just experimenting with your models, but when in production at an enterprise level, these type of guardrails become very important. So overall, just to summarize, these are basically things that you need to have when you're deploying your LLM, which is basically having everything in compliance. So if you do see there is some overlap in the kind of failure modes that you see with traditional models in production, but if you go into the specifics, the kind of drift that you see, the kind of hallucination or false facts that are generated is quite different or rather distinct that you see compared to traditional models. So I'll do a bit of a recap here on like what the ML lifecycle or a typical MLOps pipeline looks like. Well, you start off with you're mapping out your business objective. You start collecting, pre-processing data, doing things like feature engineering, model selection based on the kind of use case that you're going to solve, optimization, hyperparameter tuning, validation, whether it's cross-validation, K-fold, etc. And then basically deploying it to an endpoint and then having it ready for production and then scaling it up. So in an LLM-Ops pipeline, you still have, like, again, there is overlap here. So you still frame your business use case, you ensure and secure your governed data. You apply safety checks and tests before deployment. So basically the discipline of shipping your model to production doesn't really go away. But in LLMs, what we see that we have is the biggest levers that we have are outside the weights, things like instructions, the context that you provide the model, the knowledge base that has been adapted towards, and basically any safety policy behaviors or guardrails. So these do come under things that you see in an MLOps pipeline, which is introducing guardrails or basically feature engineering. But the type of feature engineering we do for LLMs is a lot different. We don't really call it feature engineering. It's things like prompt engineering, instruction tuning, knowledge adaptation or domain adaptation towards LLMs. And the way we end up fine-tuning it is not necessarily hyperparameter tuning, but we do make different tweaks to the model architecture. So we can't really use the same MLOps pipeline that we have. There do need to be some tweaks that we make that can fit based on the LLM architecture that we have, the kind of failure modes, like I mentioned. So that's why the LLM ops pipeline ends up being tweaked a little bit. So if you notice where you'd have feature engineering, you end up having like a prompt and context design. In your hyperparameter tuning, you start having things like targeted adaptation. A few examples which are quite common are things like LoRa fine tuning or even EFT. So this is kind of to showcase that yes, there is still overlap of between the traditional MLOps pipeline with what you see in LLM ops, but given the LLM architecture and the kind of failure modes and how it is used in production, that being distinct, you do require like a separate distinct LLM ops flow that one can use as a guideline when deploying your LLM to production. So yeah, just to summarize, LLM ops builds on or can be considered as an extension of MLOps, but because it focuses on the unique realities of what it works with, which is language, things like context, drift, hallucination, and any human impacting decisions around that. So what I'm going to do now is basically showcase, we've identified a few things like the failure modes that LLMs have, the kind of architecture and the kind of data that we have to work with. So what I'm basically going to showcase is how we can take this into 3 cards or 3 phases when you're developing or fine-tuning your LLM and how you can go about it in production. It's quite similar to a setup that you would see in any code base where you have like a sandbox build zone, which is basically where you have your raw code or you can basically experiment with the models that you have. The next one being is your inference or your run setup where right after you've decided which model you want to go about using, you then deploy it to an endpoint and then have it as an API and then start making queries or calls to it and then introduce some safety checks as well. And then finally, your live production zone, which is a more scaled up enterprise version where you could introduce more safety checks, things like RBAC, which is user-based control, which I'll be getting a little bit into later, and also have a full-fledged observability setup. I'll also be talking a little bit more about what observability is for in LLMOps and why it's recently becoming a lot more important in this whole diagram that we see. So yeah, as we see here, this diagram here, it does resemble the staging pipelines from MLOps, but what evolves here is the LLM behavior, not just the kind of code that we use or refine or the model weights. So why does this separation of this into 3 phases matter in an LLM system? So I would say it's probably because changing a prompt or a retrieval source can end up changing outputs as much as just retraining your LLM. So feedback loop can end up causing unexpected states of change. In a traditional MLOps cycle, you still do end up having a continuous loop where it, based on changes in model behavior that you see, you end up retraining it. Here, what we end up seeing that changes is different here. It's things like change of a prompt or the kind of responses that the model gives. That's what ends up defining whether the model needs to undergo retraining or not. So it's still a closed loop system where every environment reduces uncertainty before language reaches a real person. So I'm going to do just a little bit of a zoom in of each card, basically. The sandbox environment can basically be you experimenting with different LLMs. So it would be, in my case, what we generally do is have like fine-tuning notebooks. So it starts off with loading your models, your open source models, and then just experimenting with what kind of fine-tuning setup that you'd want to have. A lot of people generally just end up having a setup for running raw prompts, loading your model, and then doing some fine-tuning on it. You could have a separate config script for that, and then having a RAG-based setup just to structure the kind of answers the model gives. So this would be your isolated environment. There's not a lot of safety checks that you have here. It would just be you doing quick iterations and quick fire prompts to the LLM to see what kind of responses it gives. This is basically your experimental setup here, or your zone for behavior discovery of the LLM, essentially. The runner environment now, basically, in the previous setup, what we did was we probably decided what fine-tuning methodologies work for us, which model we'd want to use, and also decide what sort of fine-tuning techniques applied, whether it's LoRa or some form of instruction tuning, and also preparing our training data sets. So once we have that notebook sort of ready, we could probably move to the next phase of deploying it to an endpoint and start making queries to it through an API. Generally, what we see in like use cases nowadays for GenAI solutions is chatbots. So probably deploying it to an endpoint or having it as an API makes sense here. This is also where we can slowly start introducing some responsible AI principles or safety tests. So one thing that we see that's quite new is like a prompt regression suite. This is basically a fancy term for someone where you have a list of prompts. You're basically refining it based on the responses that those prompts get from your LLM. So you could set your own metrics or guidelines on whether the response that you got from the model passed or failed or was sufficient enough based on the prompts that you feed to it. Based on different scenarios, you can run tests, and based on the metrics that you define, see whether the response to those given prompts failed or passed, and then accordingly refine your prompts based on the results that are recorded. So this is basically a tool or like a set or framework that you can use to help understand how well your model responds to certain prompts. Maybe more context is required. Maybe it's not necessarily adapted towards that domain. Maybe the structure of the prompt needs to be different. So this can sort of act as a framework for you to understand how your model responds to different prompts and refine them accordingly. As we spoke about earlier, drift detection. One thing could be like semantic drift, which is, let's say you record prompts over a period of time over different topics, and you wanna basically record the change in tone or the context that of the prompts that were fed to your LLM. You could have a side-by-side comparison of histograms that showcase the change in context or the set of topics that of the prompts that are being sent to the LLM, and also record the kind of responses that are given to it. That could be an example of drift detection in the case of LLMs. And of course, all of these things can be tracked on a tool like MLflow, where you can just have version prompt templates, also track the model response, and also compare it with any metrics that you have, like accuracy and whatnot. So yeah, your runner environment is basically the next step, moving from your raw code to introducing some safety tests, having it deployed in an inference type setup. Basically, you're moving towards having it ready in production. So why I've defined this as a production environment is basically, yes, we've now deployed our model to an endpoint. People can make queries to it, but generally what you see in real-world projects is having them at scale. So, and also introducing a lot more guardrails and like safety principles. So one thing could be like having stricter prompt templates, where you basically lock the conversation your LLM only speaks to like vetted version control templates. But one problem that I see through this is unless the users or customers are aware of like this strict prompt template to follow, if they do give questions, the model ends up not answering quite well to it. So another principle that I would suggest, where instead of giving like strict prompt templates, you could introduce something known as RBAC, which is a role-based access control, where the admin or the person who's deployed the LLM could assign users to appropriate roles, and that defines how they interact with the model that you have in production. They're assigned roles, and then that basically defines authority level of probably the types of conversations that they could see, what sort of queries they could ask, and based on that, they could get a response. I've noticed that this is quite useful in like internal projects where it's let's say someone is working on like as like a mortgage underwriter assistant, and you have various roles like an admin, an analyst, an accountant, and all of them need to use the same LLM, but the kind of queries they ask is quite different. So in those cases, assigning different roles and permissions on what they could ask the LLM can help guide the LLM through their conversation and help them sort of compartmentalize the kind of queries they ask and the kind of responses they can expect to get. Also in a production setup, you also would want like very strict logging principles and also audit trails where every LLM decision or response leaves footprints. All of this needs to be traceable and reviewed by whoever has deployed the LLM. So basically what I'm introducing here is like an RBAC setup where based on the type of the type of queries that a user would want to ask, you could have the same LLM to do that, but based on the kind of permissions that you assign the user, you can sort of restrict them to just focus on their own role and the kind of queries that they want to ask, rather than having multiple users asynchronously just give different queries. So that sort of confuses the model and can make it more prone to things like hallucinations or even giving straight up incorrect answers. The last part that I want to talk about is observability. So observability in LLM systems is basically you extend like traditional MLOps, where you monitor the model behavior, in this case LLM, in real time, not just things like prediction metrics. So what we'd end up doing here is, as you can see, it isn't just a one-time check. It's a continuous loop that keeps LLMs aligned with user and business expectations. So this would be quite similar to what you see in like an observability or monitoring setup in your traditional ML lifecycle. You do your data collection, logs, and performance data. In this case, it would be user prompts, the LLM responses, and any safety signals or flags. So these would be like highly dynamic artifacts because you would have multiple prompts and subsequent responses coming in, which are still unique to the LLM that you've deployed. Other things that can be collected are, of course, embedding insights and data relationships, etc. You'd also collect things like user feedback, because the next step that you have to go to is something like the prompt regression suite that I was talking about earlier. If users aren't happy with the kind of response that the model gives, you could go back to seeing what kind of prompts they gave, whether it's in alignment with the kind of prompts your model expects, whether it's the structure of the prompt, perhaps it requires more context, and basically do some sort of root cause analysis and try to identify where the issue is, whether the prompts need to be more refined, if the model requires more instruction tuning, things like that. So it's a dynamic, continuous improvement process that you can do to the LLMs based on context that you provide, whether it's prompts, LLM outputs, and different safety signals. All of these, of course, would be monitored. You could use tools like MLflow, or one thing that I think is quite useful is the ELK setup, which is Elasticsearch and Kibana. This can also be used to like monitor things like what I mentioned earlier, like semantic drift, the kind of prompts and corresponding outputs, so that both the users and the person that's developed the LLM agent can have an understanding of how the model performs based on the different prompts provided. So I'm quickly going to walk through the setup that I have based on this 3-tier LLMOps architecture that I followed, and show very quickly a small app that I've built based on this. So as you can see, you have your sandbox setup. Your sandbox has your fine-tuning pipeline, and then of course, an evaluation setup. What you have generally in your fine-tuning pipeline is obviously your environment setup, your various libraries, and also your model configurations. This would probably define what sort of fine-tuning you're doing towards the model, and just in general, your entire training setup here. Of course, you have like model evaluation, and then all of that I've condensed into like a sandbox from playground. So this would be basically where you could do like quickfire, iterative experimentation with your fine-tuned LLM, where you just quickly feed it prompts, see what kind of response it gives, and evaluate those and make changes accordingly. So this would be like sort of an isolated experimental setup. You don't really have any guardrails here. This obviously wouldn't go into production because it's not, there aren't any compliance rules that it follows. This is more still your experimental setup where you just feed it quickfire prompts and see what kind of response it gives, and then decide what sort of changes you need to make, whether it's instruction tuning or any other fine-tuning techniques. Once we've probably decided that, you can end up going into the runner that you have. This is where I'm going to introduce some of the more safety checks that I've mentioned, which is things like hallucination detector, the prompt regression suite, and have all of that condensed into like an inference script here, which is basically, in this case, a fast API where you can deploy to an endpoint and then pass queries to your model with some context, and then it gives outputs. So this is basically, as I mentioned, where you introduce some safety checks and then have it in like an API setup to feed it queries and then get responses accordingly. When we're doing this at scale and also trying to do some role-based access control, that's where I have a production setup. Once again, you have your app script where you condensed everything into a fast or a Flask API. Introduce some more safety checks where you can have everything from the LLM, whether it's prompts or it's queries, traceable, so you could have that in an audit script. And then the two other things which I mentioned, which is if you'd like to introduce like a strict prompt template that the model follows, which basically would mean that you have to provide this given prompt that I mentioned here to the LLM when you're feeding it any queries, otherwise it won't give any responses. If you'd like to just compartmentalize what sort of user and how they can interact with the LLM, you could just have a RBAC setup where you just define the different users and their roles and permissions, things like whether they can chat with the model, whether they can look at previous logs or conversations, things like that. So yeah, this is basically you transitioning from just having your model deployed to an endpoint to having it be able to deal with things at scale, whether it's customer queries, tracing conversation logs, or even compartmentalize which user and how they can access the LLM and in what way. So I have very quickly like an example of a Streamlit app of the same thing in production. So let's say here I log in as an admin user. That's the role that I've assigned here. Let's say this is the LLM that you have in production. What you could give someone is the model configurations that can be easily tweaked, not things like LoRa adapted or tweaking things about the model architecture, but things that are more related towards the instruction of the prompt that you're giving. Things like temperature, the context length, and risk sensitivity. These are things that not just you as a developer can tune and then view responsive, but also customers can play around with. So let's quickly give a case here. So I'll probably, since I'm the admin user here, very quickly give the model some context on what it does. This is just to showcase that the model here, being a mortgage underwriter assistant, what its tasks are, so that it has some context on the different users, what kind of queries that they could end up giving. So we could switch to the next user here. Let's say here he is. So let's say in this case, the analyst is someone who's going to analyze the production case that's given here, which is something regarding the various loan policies that are being given. So he goes to the same case. The analyst, as we've defined in the RBAC setup, is someone who can have access to conversation logs and also can tweak around or play around with the types of prompts that he sends. So let's say the analyst is someone who's going to provide one of his underwriter cases. He can also experiment with how the data wants to be classified. This is also something that the LLM can record, whether data needs to be PII masked or confidential, because that is something that can be logged in the monitoring and governance setup. So let's say he provides multiple cases. You can see how the model responds differently based on what you classify the data as, whether it's supposed to be internally logged, if there is some PII masking added to it. So the model can understand tone of how the data needs to be handled based on any tweaks you make to the context or the prompt that's provided. So these things, this is basically to showcase based on the different roles of people who have access to the LLM, how they can, what kind of prompts they can send, and how in case of an internal product, how this can be used by different users. The same LLM, how it can be used by different users based on the roles. Going a little bit into the things that can be tracked. One thing is obviously the various prompts that are being set, how those are classified. So this is basically your traceability aspect based on the different prompts and the corresponding model response. Those can be tracked and also how they are classified. You can also other monitoring metrics could be things like the various number of queries over a period of time. This could be visualized as semantic drift based on over a set of period of days, the various queries that are asked, the kind of topics that they encounter, or the tonal shift. Another thing could be like average latency or total latency, the queries per role, just if you want to classify based on the different users who have access to the LLM, the kind of queries that they were sending. And then finally, like data governance. So this table would basically simulate your data governance use, where how sensitive prompts are flowing. So if you classify some of them as PII masked, those would be logged. This is basically to showcase the different aspects that in your LLM chatbot setup that can be tracked, whether it's the prompts themselves, how they are classified based on their nature of sensitivity. So this is kind of like in an enterprise setup what your LLM would look like in production, the kind of principles from LLM-Ops that are to be applied, and how this would look like in an enterprise setup. So I'd like to conclude just with I'd just like to conclude with some best practices and anti-patterns that you could have as a guideline when deploying your LLMs in production. One is obviously it would be good to have your prompts versioned and tracked using a prompt regression suite so that you can keep track of what prompts work for your model and what fine-tuning is required based on that. Having them as free form where anyone can say anything can tend to things like hallucination or even prompt injection happening, which brings me to my next point, is maintaining guardrails as code. Tracking baseline prompts is also a good idea, where you have a set of basically ground-truth prompts where you know the model performs well on, and then if various customers or give queries which are somewhat similar to those, you can see whether the model actually understands the semantics of the prompt that you provided or just understands keywords. So these are a few like best practices and anti-patterns basically of what your LLM in production should and should not have. This is in our emphasis portfolio, various set of projects that we have all the way from NeoRegal to NeoCrux and AIOps. These basically focus on like generative AI solutions which go over various aspects of like the software development lifecycle, where we have implemented various of these LLMOps principles, whether it's a prompt regression suite, traceability of the various conversations that we have and how they can be used in various aspects of the software development lifecycle. So yeah, these are the resources that I have for someone who's trying to get into deploying their LLMs into production. One thing that I would say was very useful when I was still experimenting with deploying LLMs in production was GCP's tool, which is Vertex AI. They do have a separate Gen AI studio, which has things like feature store, a separate setup for deploying either custom models or auto ML models. So I would definitely recommend that setup for anyone who's trying to deploy LLMs from scratch. These are a few other links to various papers and code bases that I used for this presentation. So yeah. Yeah, any questions, I'm happy to answer them.
I'm sorry, could you go back to the previous slide just for the list of?
Sure, yeah.
And are these, I've had trouble getting speaker decks from the schedule. Is this deck available somewhere? Or?
Oh, I've not uploaded it to the Drive slide, the Google Drive yet. I could do that, or I could just provide it to you if required.
Okay, super. I'm sorry, I missed if you mentioned if there's, I know this was broadly on LLM-Ops, but in terms of LLM observability frameworks, there's seems like there's dozens of them that have appeared in the past year.
Right.
Do you have any that you've used that you've been happy with, or do you have any brief comments on the observability frameworks?
So I think the ones that I find work probably quite well are ones which are still quite similar to what you'd see in a traditional MLOps setup, where at a high level, it still focuses on things like collecting the right data, doing tracking everything, and then probably the most important setup is like a human in the loop setup where based on user feedback and a ground truth that you have, you refine, you do root cause analysis and then refine and decide what you want to refine, whether it's the prompts, maybe tweaking a certain other part of the model architecture or instruction tuning. So I don't think I can name off the top of my head a specific framework that is useful, but I think the ones which mimic MLOps frameworks for observability are probably the ones that do work the best in an LLMOps setup. What ends up changing is just the kind of data that you're working in, whether it's prompts or LLM responses, and then how you end up addressing those.
A great talk. So I have a question. So in your drift, I'm interested in the drift. So what signal actually do you find most useful for detecting like the drift in the LLM?
Oh, okay.
What's the signal? Yeah.
So I ended up using a Jaccard score to kind of measure semantic drift. So basically what I did was, over a period of like a few days or maybe a week, feed the LLM like prompts on different topics. One could be on like different types of loans, and then see how the model responds. So yeah, semantic drift, as you can see, is just basically changing the tone or the topic of the prompt that I'm feeding it, and then basically see how the model responds. And then I'm just recording like from vocabulary shift. You can see towards the top that it's at some points it does flatten, where I was going over different topics, but there was some overlap in what those topics contain, basically what I was feeding to the prompts, and the LLMs sort of gave similar responses. But if there was a complete different change in topic, the kind of responses were different. So that's kind of how I ended up visualizing semantic drift.
Okay, how often do you do that? Like check this kind of drift. How often? Like in 2 weeks?
Oh, this was, I think, over a week. Yeah.
Oh, wow.
I mean, ideally, you should, for this presentation, it was over a week. Ideally, it's an iterative process where you do it every few weeks based on the kind of queries that you want to use. And then just look at this would be probably useful to just, in an enterprise setup, anyone who's working with various types of customers to monitor
Yeah.
what kind of response prompts are being
Yeah,
given.
yeah.
So just doing that every few weeks would probably be good to see. First of all, like how often people are using the LLM, and then what kind of questions they're asking it. Maybe every few weeks, the same user gives like different queries. There could be a reason for that. So it's probably just good to do it every few weeks and see if what kind of shift in tone or semantics that you see, and then go about seeing why that ended up happening.
Okay, all